So here I am in the lab with my lovely wife, and we've been doing some sort of home renovation work, and I want to show you what we did. If we come outside here, we turned the living room into our home dance studio. So that required us to do a lot of moving and organizing of stuff, which led us to really discover the hoarding. You're going to be able to relate to this, I'm sure. The topic is hoarding. I have a storage room over there that has about 20 years of projects in it. And my wife is like, hello, what is all this stuff? When are you going to throw this away? And it was at that moment I realized that I had an unhealthy relationship with this stuff. I've been dragging it around across continents. And when I think about it, like, it has no real value. You can't sell it. You can't really reuse it. You can't do anything with it except be trapped in sort of an emotional pit of the past. So I think throwing stuff away and clearing it out is going to be really good for me. But it's also going to be painful. I realize that over the years, you get into this mentality where you put thousands of hours into some idea. It's like your hopes and dreams are invested in this invention or prototype that you're creating. And then years later, you look at it and it evokes all those emotions. And it's really difficult to objectively say, this goes in the trash, move on. I'll probably edit this part out.
Good.
Here we are coming into the storage room. I want to ask you, how do you feel about this when you see it? What emotions come up for you?
Well, I am very irritated because everything is dusty. Very irritated. Why can't you just throw some away? Why can't you just throw some away?
Exactly. So that's where we are. Wow. So where do I even begin with all this? I guess it's like any other daunting project. I just got to start somewhere. Just dig in, try to find the rhythm of it, and then keep going. So here's the first box. I thought I'd start with something that wouldn't be too challenging. This one, it's called IR Pixel. Let's see what it is. Garbage. Oh, art supplies. Here we are. So the idea of this was to make a painting or an artwork that was only visible using an infrared thermal imaging camera. So I was doing experiments with making like little heater pixels that would be stuck invisibly behind some surface, and you would drive it with some electronics that would heat up the pixels in a pattern and create images. And you'd use sort of like the false color of the thermal camera to kind of paint with it. Kind of cool idea, but it's just never going to happen. So let's just throw it away, painfully. Now here's the funny thing. This is like, this triggers a hoarding instinct in me. It's like, oh, don't throw that away. That's brand new. It's a perfectly good easel canvas thing that you could use or give to someone. And it's like, okay, really? Are you going to invest the time to find someone to give it to or keep it again? No, we're going to throw all this away. That felt good. Here's another interesting one. This thing I called the LE Doodler. And basically, it's a matrix of addressable LED pixels. Let's open this thing up and take a look at it. See? It's garbage. It's already rotten, falling apart garbage. The idea is we have this array of LED pixels in these little pockets, and these capacitive sensing wires that cover it. And then we have these little sensing boards that I designed along the edge that make a row and column capacitive sensor. So it was like a giant sort of LED touchscreen idea to create little animated pixel art where you'd put a diffusing screen over it. I guess that's what this was. And you basically, as you move your hands around over it and touch it, you could control the LEDs. That's all RGB and everything. And yeah, just throw it away. There we go. And this, obviously I can keep this because it's just a piece of acrylic. I know. But I have a laser cutter, so this is very useful. That's part of the deal, is I realize there's a lot of things that I can condense down to just like parts or materials that are generic enough that I will obviously use it and use it soon. So that stuff I can keep. Okay, now this thing is really, really symbolic to me of exactly this whole concept. This is my kinetic clock. I made this probably in like I'm going to say 1987 or 1988. And let's open it and see what the hell it is. Okay, it's a clock, but a clock with stepping motors. Look at this crusty old belt here. That's an old belt. 2 stepping motors that drove the hands separately and independently, right? And a computer, which I think is actually based on the 8085 power supply, transformer, little control panel, hours and minutes, start, whatever. So this was a really interesting project. I actually licensed this to a company that was going to make it as a sort of a consumer novelty product. The idea is that this would tell time like a regular clock, but then every minute the hands would do crazy stuff. They would dance around, do little weird vibrations, and basically just entertain you with monkey business. So the whole concept of like creating this and getting a licensing deal, which ultimately kind of went nowhere, of course, but it was deep and thick of anticipation and emotion and pride and all that, because this was pretty cool. But in the end, it goes nowhere, and time to let go of it. So off to the garbage it goes. This is something that everyone can relate to. It's that box of 3D printed stuff, that full spectrum test fixture prototype. So this is some manufacturing tool from a long ago business thing that, wow, look at that. Look at that crazy thing. That's kind of cool. Look at how much crazy work went into that. That's madness. But it's beautiful. Oops, looks like I'm going to have to throw it away. And look at this. Wow. It's a 4-headed RJ45 monster. But I think if we throw this away, no one would be the wiser. Lots of steel ball bearings. Oh my God, the bag is disintegrating. See, that's what you get. Here's an interesting box. SensaCell long-range sensor development. R&D projects of sorts here. Okay, so here we have a prototype of some concept thing. I think what this is a video camera, like a black and white NTSC video camera, and then pairs, I believe, of emitters and detectors somehow that did something, right? I have no idea really what this was or how it was supposed to work, and yet it's been following me around for a long time. So we throw that away. Ah, look at this. Another bit of R&D. So this was a SensaCell module. It's part of a business that I was part of where we made these tiles that had capacitive proximity sensors and LEDs. And here in the middle, I've hacked in a little infrared camera module with the idea that I could extend the sensing range to have both capacitive sensors for near stuff and this guy for sort of a long range, bigger picture. So, and I think this totally didn't work, as I recall. That's why it's dead in this box. Okay, this box I think is going to be emotionally the most difficult one, and maybe you'll understand why as we get into it. The virtual clock. You may have noticed there's a theme of obsession with clocks going on here, but nothing I can do about that. So this thing So this is a complete product that I developed in sort of probably late 90s, I'm going to say. It's basically another clock, and it functions by spinning around these LED bars, which plug in like this. They just plug in. And the whole thing plugs in, has an infrared remote control. I wonder what the batteries look like. Ooh, that's nice. So the remote control allowed you to, you know, set the time, change a bunch of stuff. Get rid of that. Here's the user manual for the thing. I guess this was maybe a prototype. It shows all these different aspects of it. I think we even got this thing UL approved. That's how you install it. Now, probably it still works. I can't imagine why it wouldn't. But the thing is, first of all, this one I know is set up for 110 volts. It's also set up for 60 hertz. So even if I could get that remote to work, here where I am in Thailand, this thing's never going to work right. So I think I just have to throw it away, which is very painful, just considering this is the only sample of this thing that exists, and it was such a major project. Like, I think I borrowed money from my parents to fund the development of this thing, and it wasn't tremendously commercially successful for kind of reasons that should be obvious. It's a really cool thing, but the problem is that, like, okay, it takes AC power, so if you're going to install it somewhere, you have to put a dedicated outlet behind it so that you can get rid of this. And it's big and it's pretty dramatic, so it takes a very special kind of space to make use of it. And in the end, that is a very rare animal. So as a result, we sold only a few of them. So that's the story of this. So let's throw it away. Cringe. shutter monkey. Yeah, not much to see here really. Mostly what happens with these is that over time the contacts, or the pads on these things tend to oxidize, which makes them pretty much unusable because it just doesn't solder anymore. I think you can see that I'm struggling a bit with these parts bins because, okay, this is difficult for me, but I did it. I threw it away. Okay, that's short for robot. When I was doing my robot project, I got really into making these laser cut sheet metal parts, which are really fun to design. You use the SolidWorks sheet metal module. And the whole idea here is that, like, I don't have a brake or any fancy sheet metal stuff, but if you just perforate these things in the right way, you can bend them, and it makes really nice clean bend lines without having to have fancy equipment. So I can make really complicated stuff like this, and I think I basically just use some C-clamps and blocks of wood to bend all this up. And then when you screw it together, you can make these incredibly strong sheet metal things without any kind of fancy tooling at all. Like, what's going on here? Laser pong. Okay, this is definitely an interesting client project. I like these fun ones. Take a ping pong ball and figure out a way to make it levitate or float in a glass tube suspended on a column of air. This crazy thing contains a servo, and I think it's a valve basically, and the servo operates the valve, which caused the airflow in the tube to change to be able to levitate the ping pong ball. This thing, it's actually a speaker. See, it says 4-ohm speaker, right? This thing was what we used to figure out where the ping pong ball was in the tube by basically bouncing clicks off of the ping pong ball. We could measure in real time, very accurately, where the ping pong ball was. And at the bottom of this thing, we had an RGB laser, which I don't have any evidence of that left. But the RGB laser basically illuminated the ping pong ball. So by closing the loop on this thing with a bit of electronics, we could make the ping pong ball hover or move, do whatever we want, and illuminate it from the bottom with an RGB laser. And since these are translucent, it glowed beautifully. As I recall, the RGB laser we had was like a 3-watt version, and if you turned on all 3 lasers at once, the red, green, and the blue, and just let it sit there, if the ping pong ball had any of this black paint on it, it would actually start to melt because it absorbed the light. The white part did okay, but it was marginal for sure. It worked fine when the air was flowing because the ball's constantly spinning and it's got cooling air. But this was really cool and really beautiful. This clearly is a little fan system that has a little like homemade duct on it. So here is tubes with little microphones in them. This is part of that ranging thing. So together with this speaker pinger thing and these microphones, that's the prototype of how we range the balls. Very cool project. This one gives me a little bit of cringe, mostly because of how the coolness factor of it. I kind of go like, wow, that was really cool. Oh, look at this. I might keep this. So this was the circuit that controlled it all. I'll keep that because it's small and just put it in a box. All right, so this one says Light bar, light ring, prototype samples. Wow. So you're supposed to view them like this, and they shine light and it reflects off the wall. And in the ultimate design, we refined this down to just 4 pins because you just need power, ground, DMX plus, DMX minus. And they ended up fitting into these injection molded plastic housings. Yeah, so here's a board. Here's the LED side, and then these pins made up with these contact points. And then you just, yeah, there you go, it just shoves in. And that's how it makes contact. Pretty slick. Don't need it. On to the next job. So I think it's pretty obvious that this whole process has been way more emotionally difficult than I had ever anticipated. Going through all this stuff has forced me to take a really long, deep, hard look at my career and my life from the perspective of all this physical stuff that I create and invest a lot of physical, financial, and spiritual energy in. And dragging it around and keeping it is such a cop-out. I feel like the strong thing to do is just to experience it, look at it, throw it away, and make room in my life for new things and new experiences. And also just try to have a much lighter relationship with the physical stuff in the first place. Not put so much gravity in it and an expectation. That's the key thing. The expectation is, I think, where it gets a little bit weird. So I have to say, this really has been an important experience that hopefully will lead me to sort of a cleaner, lighter place where I can explore ideas and continue to be creative, but without knowing that stuff is always like there, hiding in the background, ready to remind me of things in the past that maybe are uncomfortable. So anyway, I thank you all for coming along with me on this arguably rather self-indulgent little journey, but it's been really important for me. And I thank you for watching. Please continue to support Leo's Bag of Tricks, and I'll see you next time. Check, check, test 1, 2, 3. Okay, what? Hello? Why?